We're doing a big push on security this year, and so you'll see a little bit of that theme kind of running through the day. So obviously this talk is about security threats, but we also have the pleasure of Joe Williams from GitHub to talk about a little bit what they do on the GitHub side from a security perspective. His official title on Twitter, which is awesome, is computer operator. But he actually spends a lot of time on the load balancer tier, and he just knows a lot about a lot. So I'm going to have him come out now, ask him about his commute, if you do see him around, though. He's got a pretty awesome commute from where he lives to here, but I don't want to spoil the fun. So anyways, Joe, are you around? He is. Here he comes. And I'm going to come out afterwards, so no booing, please. When he's done, I'm going to come back out. So, how's it going? As he said, I'm Joe from GitHub, and yeah, I work on the load balancing tier mostly. Let's see, I'm going to talk a little bit about attack vectors that we've seen, some mitigation techniques. There's a whole variety of tools and things that we've built to deal with things. Some of the stuff we use to dig into any sort of threats that we see, or a lot of our monitoring, and then some of the testing that we do to make sure that changes we roll out are actually doing the things that we want them to do, and then some future stuff that we're planning to do, and things that you guys can do on your side to hopefully deal with the things in the same way. Let's see. So there's a whole list here. The big attack a couple of months ago is basically all of these. The largest part of it was the top one, which is the JavaScript injection. That was presumably done on the Great Firewall of China, injecting JavaScript into unbeknownst requests. But then there's a whole host of other things that during that attack happened, and so that really runs the gambit. What was interesting specifically about that attack was how quickly things changed between attack vectors. So anything from SYN floods with fat SYNs to just normal HTTP GETs over HTTPS, UDP floods, hitting slow URLs within the app, also hitting marketing sites and that sort of thing. So for instance, we have enterprise.github.com, which is our enterprise product marketing site. They figured that out and decided to start attacking that, which happens to be on a smaller infrastructure than github.com. And so we had to mitigate that attack and move things around to kind of deal with it, because generally that site doesn't get nearly as much traffic. And then also attacks on our DNS and CDN providers. So in this case, Fastly helped us out quite a bit dealing with the attack that they saw, because they were hitting Fastly quite a bit. So some of the techniques we use, and this is what I call the normal stuff, which is probably stuff that you're already doing possibly, but stuff that's pretty common, I think. We use a provider to do traffic scrubbing. There are a number of these. I can't state which one we use, but it's pretty easy to find out. And then we have security devices at the edge. These aren't firewalls, but they do give us insight into the traffic that's coming across and mitigate some classes of threats. And then we use HA proxy a lot in our infrastructure, and that's continuing to be even more so in the future, I think. And a lot of the examples I have coming up are HA proxy config snippets. Hopefully they're at least somewhat legible, and I think that for the most part you could port them to any load balancer software or hardware that you have. So at the very least you can read the documentation and figure it out. So one of the things I think that we do really well is to be able to make fast configuration changes, and we do that using chat ops, which is something that GitHub's known for. And so we have a few examples here. On the right side, you can see like an actual chat transcript of me banning a really bad user agent, and this happens immediately. on all of our load balancing tier. Or I guess it's targeting. And then on the, let's see, I guess on the left side, you have a number of different things. So the first one is basically sending a 401 or 403 immediately for some path. So in a lot of cases, we'll have a attacker hitting a specific URL, and we just want to just send 403s constantly to any sort of request to that URL. It's kind of heavy-handed, but at the same time, we can mitigate an issue really, really quickly this way. And most of the time, once we kick that in, the attack will stop, and we can just flip it back off. Another case is we can add IPs to a blacklist really quickly, and another is to turn on mitigations in those security devices we have, all from chat. And then also we can enable our scrubbing provider, just right in chat, just enable, and it's done. We generally don't leave it on because in most cases it kills performance. So we like to be able to turn it on and off as we need. Then finally, we can target user agents, like the example in the chat screen says. So one of the things that we do also is try to identify attack methods as close to the edge as we can. So in this case, this is an example of a part of our HA proxy config that basically checks for content in the TCP request and then rejects that request if there hasn't been any sort of content within 10 seconds. And this really helps to mitigate slow loaders attacks and that sort of thing. And then also what we do, and this is especially helpful in the attack a couple months ago, was identify human requests whenever we can and flag those as good. And we do that in a few kind of sneaky ways, but a couple of the more common ways is to look for specific headers or cookies. We know we set a time zone header or time zone cookie whenever you visit the website. And so we can verify that this is an actual customer that's logged in if they have that cookie, because it's a cookie that we know that the customer has. There's some other things that I'll talk about later that I think will also help this sort of thing. But also, if the browser has set the language in a header, then we know that's probably a human request. And then we also tune a lot of timeouts. So in HA proxy, there's a whole gambit of timeouts. There's like a dozen, I think. And some of the ones that really help us are tar pitting and how quickly the client responds. And in this case, the client response time is actually quite high, but in this case, it's for SSH traffic or for Git, and so we have to set it artificially high in some cases. But also, we expect an HTTP request to hit our load balancers in completion before the response gets sent back, but within 15 seconds, for instance. And so next up is visibility. So we have a pretty healthy graphing culture at GitHub. And so here's a few graphs that I'll explain. So the top left is that banhammer you saw earlier. We track how many requests are getting hit into the banhammer. So in this case, the various lines are different backends within HA proxy, and it's how many requests are hitting those backends. So we have a backend in HA proxy for each different type of banhammer. So whether that be a UA ban or an IP ban or a URL tar pit or anything like that. So we can keep track of how many requests are getting sent to those backends, so we can look for anomalies and that sort of thing. This was particularly helpful for the attack a couple months ago when we were sending tons and tons of traffic to this, and we could really see what was going on. And then on the top right, we have connections by port. So in this case, just the SSH traffic and HTTP traffic and also GET protocol traffic, which is on a separate port. And then finally, send receive for our load balancers. This is really helpful for SYN floods and that sort of thing. Or if they're targeting a specific load balancer report, we can slice and dice this data and figure out what exactly is going on. And also we do a lot of provider graphs. So in Graphite, we track lots of metrics for our providers. And a lot of that is tooling that we've built to slurp down the API and process that stuff into Graphite. You can see here that there's Fastly stuff in here. So we consume the Fastly stats API and then dump it into Graphite and keep track of that. And then also we talk to our scrubbing provider API and pull that stuff down and graph it as well, so we can watch things happen during an attack. And one thing that's hard to show in a slide deck is we have dashboards for all of this. So we have a dashboard-specific app that collates all the graphs into dashboards that we can watch. So another part of visibility is logging. We log lots of different types of headers. HA proxy kind of makes this easy, and we can do that pretty readily. Some of the things that we do that I think are interesting, we also log the GeoIP and autonomous system of the client IPs. One tricky thing that we had to figure out was how to log the Fastly client IP. So normally you just get the cache server IP, and that doesn't do us any good for finding out where that customer is. So we pass that header back to HA proxy and GeoIP on the Fastly header. So that's why you see here at the bottom, you see the source country was EU, and the Fastly country is DE. The source country is actually the Fastly cache server. The Fastly country is actually the country that the request was made from to the cache server, if that makes sense, hopefully. And then also we log the cache server itself, so using the Fastly served by header, which gives us the cache server that received the request and processed it. And so we also do lots of configuration testing, and I'll show an example here in a second. We both do it for our edge devices and services, but also for our providers. So we have a test suite for Fastly, as well as an extensive test suite for our load balancers. And those tests basically test every single ACL in the HA proxy config. It literally took me 6 months to do it. It was kind of crazy, but well worth it, because we know when we're rolling out changes that the tests are making the appropriate changes, and that they have the effect that we want. And it's literally, 1,000 lines of bash and curl, basically. So anybody can do it. So here's an example of a test run. This is on our load balancer build server, essentially. And you can see here we're testing ports, and there's basically a bash test suite that we have, or a bash test library that we use, and then the rest of this is basically curl or netcat wrapped in functions that do the right things. And so you can see here we're testing redirects and that sort of thing. The output for this, it takes like 20 minutes to run, because it actually tests all of our timeouts and tar pits as well. So we hit a URL we know is tar pitted, and we test to make sure that thing times out at the right moment. So basically we check to see how long the curl took and validate that it was over the known timeout. And then we also test for Fastly. So we have a number of tests here for ALPN, which I tweeted a little bit ago, a couple weeks ago, about how I found out that they added support for ALPN using our tests, and then went in and fixed the test. And then we also check for ciphers, and check for that we don't use the bad ciphers, and SSL fingerprints to make sure the certs are correct, and that sort of thing. And as far as future work, I think where we're going is we need better tools to identify that traffic is human. And in this case, is some sort of traffic authentication, so like a CAPTCHA, to make sure that whatever we can turn on under an attack and make sure that the request is coming from a human that's typed something into the browser and that sort of thing. Multiple CDN providers. I know a number of people are looking and working on this because, like I said, we see attacks to our providers, and we need to deal with that. And we can't just be isolated on one provider. The big problem there is feature compatibility between providers and making sure that we don't kind of paint ourselves into a corner with one provider. Same thing with DNS providers. Having multiple DNS providers, again, gives us a bigger way to deal with the traffic. Also, one thing that I'm working on right now is going to become a big part of GitHub in the future, and even in the next 6 months, is per-service configuration and architecture. So historically, GitHub has been kind of a big monolithic app, and that's reflected in the load balancing tier, which is basically a handful of nodes that deal with all the traffic for all of GitHub. And that's changing rapidly right now, where we're switching to basically service-based load balancing tier. And in that case, we'll have load balancers for each different service that we have. So whether it be github.com or api.github.com or pages or any of the sites that we host, they'll have their own load balancing tier, their own tunability, and that really helps to spread the load across lots more machines, but also gives an attack a smaller blast radius so we can isolate that traffic to a specific place. Also, one thing that's going to help us is per-service Fastly maps. So right now we're on like one map, and I think in the future we're going to be switching to more granular maps, so Fastly has the ability to push our traffic around to POPs that aren't already flooded. And then I think it's Sean's turn now. So
He shall appear. Did you have any questions for Joe before I get going?
What chat app are you using?
We still are on Campfire. So
regarding the
I got two here.
so the attack that you suffered was well publicized and hard to prevent, I think by any measure. Have you engaged with IETF or any of the browser vendors at all to try to get them to identify requests that are made via JavaScript versus interactively?
We haven't talked to any browser vendors, no.
Okay.
Since so much of your traffic is programmatic and not human-based, would CAPTCHAs actually help, or is that only?
So traffic to GitHub.com in general is mostly humans, like creating issues and that sort of thing. A lot of the traffic to the Git endpoints and that sort of stuff may be robotic, like Jenkins or Travis CI or anything like that. Also API access in our case is required to have a user agent and that sort of stuff, so we can identify problematic bots and that sort of thing. And so that's kind of how we get around it a little bit, because at least in the case of robots, they're generally only interested in the Git traffic in the actual repositories. So those URLs we can determine based on their path and that sort of stuff to send them to the right place. So hopefully that makes sense.
Hey, Joe. Great talk.
Thanks.
So with regard to Fastly client IP, how are you validating the validity of those headers? Are you using Fastly's IPs or maybe header signing or something like this?
We don't validate them. We assume that they're correct because we're getting the logs from Fastly. So.
Interesting. Okay, so what's stopping an attacker from spoofing those headers and messing up your IP rate limiting and things like that?
I'm guessing nothing right now.
All right.
So there are, in some cases, we do delete some headers on the backside before they get forwarded to, and so we know that they're true because we've set them ourselves or something like that. So we do a lot to actually delete headers that we know that we're going to use later on the front, if that makes sense. So we delete them as soon as we get the request, and then we add them back in with trusted information. So.
Thanks.
Mm-hmm. Looks like it. Okay. Cool.
Any other questions? Hands? If you have a question? Okay, right there.
Oh.
I can talk loudly.
Cool.
I'll pass this.
Well, thank you. Thanks for talking today. And my question is actually about whether you're using a web application firewall with your scrubbing center and if it's been effective, especially with the L7 attacks, not necessarily DDoS.
Sure. Not to my knowledge. Most of it's done the normal kind of BGP scrubbing kind of stuff. So.
Got it. Thank you.
Yep.
What are we, any others? Hands? The mic's like a hot potato, it just keeps, everybody's like, no, I didn't want it, just keep handing it to the next person. Okay.
Cool. Thanks a lot, guys.